this example, we are going to use the synthetic division to determine if k is a 0 or px. If not, we're going to determine pk. Refer to the remainder theorem. The note here, the remainder theorem. The polynomial px divided by x minus c equals the quotient qx times x minus c plus the p at c. And the p at c here is the same as the remainder term. If the p at c equals 0, that means c is at 0. Okay, in this case, we're gonna use the synthetic division to perform the division of the 2x to the third minus 8x to the second minus 23x plus 63 divided by x minus c, which is k, or x minus 2. So 2 is the c, or the k that we are testing. The numerator or dividend is already in the descending order. Power 3, power 2, power 1, power 0. We're gonna line them up like coefficient 2, coefficient negative 8, coefficient negative 23, and 63. Draw the line. First, bring down the leading coefficient 2, and after that, multiply 2 by the value k, or the c, to become 4. Add them up. Negative 8 plus 4, that's negative 4. And next, negative 4 multiplied by 2 is negative 8. To add them up, becomes negative 31. And next, multiply negative 31 with the value 2, which is negative 62. Add them up, that becomes positive 1. In the box here, so this is your remainder. And by the remainder theorem, so this is the value of the polynomial at the c, which is 2. Another way we can rewrite this as in the form I'm going to write in as 2 times x to the second minus 4 times x minus 31 plus the remainder 1 divided by x minus 2. So these are quotient of the qx, and this is the rx, and this is the dx, or the divisor. By the remainder theorem, the rx is the same as the p at c. Another way we say that k is not a 0 of the polynomial px, because p at k or p at 2 equals 1, not equal to 0. Let's look at another example. Polynomial function is 2x to the fourth minus 57x plus 5 and k equals 3. We're going to perform the synthetic division as the fraction at 2x to the fourth minus 57x plus 5 divided by x minus 3. If p at 3 equals the remainder equals 0, therefore 3 is, or k equals 3 is 0 of px. If p at 3, which is the remainder, not equal to 0, therefore k at 3 is not 0. And p at 3 equals whatever the number that we get from performing the synthetic division. All right, so in this case, k equals 3. So put 3 in the box. The leading coefficient 2x to the fourth, and the next one, I'm going to make a note up here. The highest power, or the leading power, is 4. I'm going to put this is power 4, power 3, power 2, power 1, and power 0, or the constant. The coefficient of each power, for the power 4, coefficient is 2. Power 3, no coefficient. That means no x to the third power term, no x to the second power term. For the x to the power first, the coefficient is negative 57. And the next term or the constant term is 5. For the line, we bring the leading coefficient down, number 2, and next to obtain the next number in the line above. So multiply 2 by the k value 3, so that is 6. Add them up, become 6. Get the next number from 6 multiplied by 3, which is 18. Add them up, is 18. Next one, 18 multiplied by 3, that is 54. Add them up, is negative 3. And after that, negative 3 times 3, that is negative 9. Add them up, is negative 4. So this is the remainder, and it's not 0. Therefore, k equals 3 is not a 0 of px. And what we found out, p at 3 equals negative 4. And if you write in the form of the quotient plus remainder over divisor, we have 2x to the 4th minus 57x plus 5 divided by x minus 3 equals, one more time. So this is x to the power 3, x power 2, x power 1, and then x power 0. So the quotient will be in the form of 2x to the 3rd plus 6x to the 2nd plus 18x minus 3 is power 0. And then plus the remainder, negative 4 divided by the divisor x minus 3. So this is the quotient. And this is the remainder. And this is the divisor. But our goal is to check whether the k equals 3 is 0 or not. And we found out it's not.